Welcome everybody back in the Crystal Clear Electronics video series. This is the third part of the 9th chapter.
Welcome everybody. My partner in this video will once again be Peter Buzash, and I'm Ambrus Zelei. Peter, I can see two pins in front of you, which you brought here as a personal item. Can you tell us about them?
Sure. Beside the programming, I really like doing sports, such as obstacle course racing. This is the small medal from the Spartan race I received from Greece after completing the trifecta weekend. The other is from Sweden, when I took part in an ultra race. I love challenges. They keep my body and mind in shape, clear my mind so I can program better afterwards, and they fuel me with all sorts of experiences.
Yeah, it's important that our brains only work well, we can only really engage with microcontrollers, if we get enough exercise and keep our bodies fit. This also has a connection to the frog at the beginning of the previous video, as the frog is performing a controlled movement, which is now done mechanically, but if you were not a human but a robot, and the microcontroller was doing the running movement controlling you, I'm sure you would win all of these races without exception.
Yes, if a robot can get around the rocks and up the hill, which is something that a lot of people are already working on, so probably when it becomes real, I would be much faster. But it's still perfectly good this way.
Congratulations for all your successes.
Let's get back to the topic since we already know a lot about microcontrollers and specifically about the ATmega16A microcontroller. Before we want to operate this device, we need to know how to load the program codes onto the microcontroller.
A separate device is needed to get the program onto the microcontroller. You can see it here on the table. It's called, not surprisingly, a programmer. It's also known as a debugger in the profession. We'll talk a little bit about that. In order to execute a series of instructions by the microcontroller, i.e. a program, this program must be implemented first and then loaded on the microcontroller. For these operations we need a PC, a proper programmer device, which we can see here, and a microcontroller with appropriate supply voltage, since the microcontroller is an active circuit element. Several programmer devices are compatible with this microcontroller, while some of them are capable to complete more useful tasks as well. Let's learn about three programmer and debugger devices. We'll only need one of the three to program the microcontroller. All three devices can be connected to the microcontroller in several ways according to the standards. We'll use the one called JTAG, because every task can be implemented with this, which will be discussed in this chapter. We'll connect the proper pins of the programmer device's JTAG plug to the appropriate pins of the microcontroller.
Let's see the programming device called AVR Dragon.
This programmer has to be connected to the PC or laptop through USB cable. As you can see in the following picture, a 10-pole ribbon cable has to be connected to the 10-pole JTAG labeled plug, then it has to be connected to the microcontroller as instructed. Detailed English description is also available for the AVR Dragon on the website. You have to be careful during connecting the ribbon cable, because pin 1 of the ribbon cable, it's usually marked with a triangle, has to be connected to pin 1 of the pin row, which can be found on the programmer.
What can we say about the ATAMEL ICE basic programmer?
This programmer has to be connected to the PC or laptop through a micro USB cable. A proper 10-pole ribbon cable has to be connected to the AVR labeled 10-pole double density plug. Then, this has to be connected to the microcontroller, the way it's written down later on.
And how is the ATAMEL ICE basic PCBA similar to that one?
The Atmel ICE Basic PCBA is the previous device's version without case. So basically, this is the same as the other one without the nice white case. The handling of the connectors is the same as the other one. Devices without case are much more sensitive to the different physical impacts, for example, mechanical impacts, humidity, and electronic discharges.
We have presented all three programmers. We will use the ATAMEL ICE Basic, and I suggest to connect the programmer to the microcontroller. But there is one more thing. The question of how to connect the JTAG connector to the pins of the microcontroller.
The first thing we really need to do is to connect the JTAG connector to the microcontroller. We will use an adapter specially made for this purpose. We have them physically here. What we'll say about these is that without them, everything in the tutorial can be done perfectly well. They serve a comfort function. They are designed for crystal clear electronics curriculums to make things easier for the students. There's a small adapter. All it does is assign the JTAG connector to the appropriate leg with these pins. If you pair them correctly next to the ICs on the breadboard, the corresponding legs will be connected to the corresponding pins on the JTAG connector. There's a larger adapter also designed for the curriculum. It also provides power, which again is a comfort feature, as we learned that a 5-volt power supply could be built separately on the breadboard. The tool saves us that work. The communication is also handled. The JTAG connector can be found here, and the pin assignment is done in the correct way. Also, a galvanically isolated micro USB communication option is available here. We'll use these, or more precisely, the larger one in this lesson, so that we don't have to struggle with the power supply. This image shows how to connect the small and the large adapter with more features to the controller. It's very important to remember what we have learned about ICs. You need to know that there is a tiny marking on it, and from that you know where the numbering of the legs start. We go from 1 to 40 for this IC. So you have to fit the adapter to the IC in the right position. Press the adapter into the breadboard over the microcontroller according to the markings. Make sure that the label 1 of the adapter is over the microcontroller's number 1 pin. This is very important. The pin rows, which are on the adapter, are exactly connected to the 5-volt, ground, and the JTAG pins of the microcontroller, and the wires of the printed circuit connect them to the ribbon cable plug, which is on the adapter. Now we can connect the microcontroller to the debugger with the JTAG connector. Connect the programmer to the proper JTAG plug. The Atmel ICE Basic programmer should be connected to the JTAG1 labeled plug. The AVR Dragon should be connected to the JTAG2 labeled plug. Now we'll connect an Atmel ICE Basic debugger. The connection is now set with the microcontroller. And it's also important to plug your ribbon cable into the socket marked AVR on the debugger.
Thank you, Ambrus. That was very detailed. Now I connect the programming device to the adapter. In the next video, we will show the connection to the computer and the power supply. Bye bye.
Bye!